All right. Sorry, we forgot the first. We didn't record the first few minutes, but we're gonna record from here on. Okay, back to it. All right. So we're on number 5 now. Okay. When design experiments are conducted in the public school systems, researchers typically choose a particular district and randomly select teachers as, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected class. Which type of sampling scheme is implemented? I put a cluster sample.
Yeah, because it's all of the 4th grade students in that class.
Yeah. Okay.
Or in that district.
Yeah. Does that make sense to you?
Yep.
It made sense to me. Okay, at a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? So that's kind of a convenient. Let's see. I have. What do I have? I have random for that.
Yeah, because all you're going to do is draw the names up completely random. It wouldn't be a cluster because everyone's in there.
Exactly. Yeah. So you're just randomly taking it, and
Okay.
Yeah. Okay. 7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats. Now, and then they took like 100 people, and then they took registered Republicans, 100 people. Which type of sampling scheme was implemented? I put stratified for this.
Mm-hmm. Yep.
Because it's broken into demographics, and then a sample's taken from each.
Yep.
Okay, so a survey was taken of purchases at the Crossroads. Open the data file Crossroad Purchases Excel for 221 and SPSS for 222 and 223. Okay. Using software, calculate the mean of these data. Okay, so I think I still have the numbers in from last night. Let me share. Let me share my. Where is it? I don't know. It doesn't have the option. Hold on. I don't know why this is not an option. Let's see. Okay, it's not going to let me share. I don't know why.
I have it up.
Okay. So I entered, but this can't be the right numbers. Let's see. So I need to look up those numbers again. I mean, I have my number written down from yesterday, but I want to make sure that we have the same thing. Yeah.
Good call.
Okay. All right, Crossroad Purchases. Crossroad Purchases. Sorry, let's see.
You're fine. I'm doing it the old-fashioned way.
Oh, okay, that's good. do it both ways so we make sure you have the right answer. Where is it? Hold on. Oh, here it is. Okay. All right. Okay. I'm just using that quantitative data thing. Copy. All right, and paste. And I want to take it and sort it. Smallest to largest. Okay. All right, so I have the mean as 4.771.
What I have?
Good. Okay, so let's choose that on that form. Okay, so 4.771. Okay. And it says using software, collect the standard deviation of these data. So I have, go back to it, the standard deviation as 1.912 if you round it up. Do you get the same thing?
Yep.
Yes, okay. So 1.912. And then it says, I created a histogram representing the amount spent in Crossroad purchases. True, because it's on that document. Do you have that document, a copy of quantitative descriptive thing?
No, I don't, but I made a histogram.
Oh, well, good for you. Because it kind of have like, kind of a little higher on the left than it is the right, but it's pretty symmetric.
Oh, crap. I didn't put them in largest fit.
Oh, yeah. So, yeah, I get kind of, let's see if I can try to share it again. Hold on.
I did smallest to largest. Is that what you did?
Yeah.
Okay. Yeah, then it's right skewed, I guess.
Okay.
Or left
a
skewed.
little. It's a little bit right. It's a little bit right skewed, but it's
We have a little bit of this.
Okay, I'm in a meeting, and then after. Okay. Let's see. Let me see if I can screen share again. It's now it's gonna let me here. Okay. Share. Okay. This is what the little document, the quantitative document, has. Do you see it?
Mm-hmm.
Okay. So it's kind of right skewed because it's a little bit higher, but it's pretty symmetrical. Like
Yeah.
it would be considered bell-shaped because it's like, so.
Yeah. I get it.
Okay. So let me go back to. All right. So, okay, Jessica Meir and her research team measured the body temperature of sample diving sills. So all the stuff is down here. And it wants us to kind of complete the table and answer questions 12 through 15. So this is where I kind of went a little, like, got a little bit lost and forgot a little bit about. So, but if I enter, like, those numbers into that data, so I'm just going to, I'm going to clear this content. Okay, and then I'm going to enter this numbers in here. Okay, so 37.91, 37.25, 38.98, 38.16. All right, and then I'm going to sort. All right. All right, so, okay, so basically for, all right, so basically for 11, it wants us to find the value of A, and I took 30.
Isn't that just the standard deviation?
Yeah, I think it's well, it's the deviation from the mean. So it shows kind of what to do right up there. It says x minus, which is the 37.91 minus the, I think that's the mean. So the mean I have as 30. The mean is 38.075.
Yeah.
And so I took 37.91 minus 38.075, and I came up with the number of negative 0.165. What did you get?
What was the mean again? 38.
Yeah, the mean I have is 38.075.
Yeah, that's exactly what I get.
Okay, so you get negative 0.165?
Yep.
Okay. Okay, and then it says, what is the value of the number that goes in position marked with B in the table below? Okay, so that you have to factor out, so you have to do 37.25 minus 38.075, which is the mean. I get a negative 0.825, and then you have to go and square that, or square it. So then I get a negative 1.506. What do you get?
I got 0.68.
Okay, let me see.
Because if you square a negative, it's just like squaring a positive. Negative cancel.
Okay. Okay, let me see. 37.25 minus 38.075. Okay, and then oh yeah, I get that too. I'm sorry, I must have just done some math wrong yesterday. So
I guess it should be 0.681.
Yes, 0.681. Yes, you're right. Okay, so that was which one? 0.681.
Well,
okay. All right, and then what quantity is equal to the sum of the numbers in the squared deviation column? Is that right? Let's see. That kind of skipped something, I think. What quantity is equal to the sum of the numbers in the squared deviation column? Oh, so we have to do the whole, like all of those, and then find the sum. Okay. I guess I didn't do that right either. Okay, let's see. So for the other two I got in the squared deviations, I got 0.164 and 0.007. So I'm going to add those all together. I get 1.023.
Likewise.
Okay, so
Isn't that the standard deviation then? How much it goes
Yeah, I think so.
up and down?
Yeah. Well, but you have to take that number usually and square it again, I think. But I'm not sure. I'm like, that's where I'm like, maybe I need to go back. It's not the variance, is it?
It's not the mean.
It's not the mean. It might be the variance, but I'm not sure that might be.
I don't think it's the variance.
You know what? I think it is. I think that's because like on our chart, I think that was the variance, and then you usually did one more, which was the. Let me see what my cheat sheet says about the variance.
So I Googled the word variance because I couldn't remember what it was, and it says it's always a non-negative. A small variance indicates that the data points tend to be very close to the mean expected value and hence to each other, while a high variance indicates that the data points are very spread out around the mean from each other. So that would kind of fit the bill here. I mean, our means are like our temperatures are pretty close to each other, and that number would be smaller, I guess. So it could be a variance.
I think it is. Let me go to that chapter really quick and just see what they say for that. Let me see. I'm going to go back. What chapter is that in? That's 3?
Yeah, I think that's 3.
Okay. Let's go to okay. All right. So let's see. Where does it talk about the variance? Okay, it's going to be 5.1 up here. So let's go down. Okay. You know what? I have it in my quantitative descriptive thing here. Variance is 0.511 of this data. So that is not right. But it's not the standard deviation either. What do we got? We got 1.023.
Yeah.
Let's see. Let me go back to the chapter, read a little bit more. I'm trying to find the calculating the standard deviation by hand. Okay. All right, I'm almost there. Sorry, I'm trying to. Okay, so it says that you divide the sum of the squared deviations by n-1, and then write this at the bottom of column 3, but there is no column 3. Let's see. Yeah, I don't know. It says, okay, so if we go from our chart where we're at, which I think we did that correctly, it says the sum of the square deviations is 2.20. And then it says, for step 5, divide the sum of square deviations by n minus 1, and then write the value at the bottom of column 3 of your table. The number you computed in step number 5 is called the sample variance. So it didn't tell us to do that. So it just should be the sum of square deviations 2.20, but I don't think that's our option.
So then it's none of these are correct.
Yes, I think you're right. Because the sum of the numbers in the square deviation is just that. It's not anything. It's not the variance, because you have to do another step to get the variance. It's not the standard deviation, and it's not the mean.
Okay.
And if I look at my quantitative descriptive thing, it doesn't match up to any of these numbers either. So unless we did our mathematics wrong in those first couple steps, but I don't think we did. I think it's the none of the above. Okay, so what is the standard deviations of these temperatures? Round the answer to 3 decimal places. And then I have for that one, just from my quantitative thing, I have 0.715. But we should do it by hand just to make sure. So if I take the sum, which was 1.023, and divide it by n minus 1, what's n minus 1? Oh, it's the number of statistics minus 1. So in this case, it would be 3 divided by 3. So 1.023 divided by 3 is 0.341. And then, according to this, we would take that number and then we're going to take the square root of that to get the sample standard deviation. So I get 0.584. And what was the answer I got from the... I got something different. Let's see. No, I got 0.715 in the app. So what would it be? Somewhere I'm doing something wrong. I'm just going back over my math just to make sure.
Okay. I guess I can tell you what I got.
What did you get?
0.62.
I think that's what I got when I did it by hand, like 0.680. Yeah, 0.682 or 1.
Yeah, and I got 0.619. So.
Ooh.
0.619. But I used the whole numbers that I got. Does that make sense?
Yeah, I'm trying to calculate up, but let's see. 0.085 squared. 0.007. Okay, now I'm going to add these all again together. I still come up, oh, let's see, that's what I did wrong. Okay, the answer was 1.023. And then divide that by 3. I get, okay, that makes a big difference. 0.341. And then square that. Okay. I get 0.584. What did you get? I know.
0.619.
Okay, so I get, when I add all the numbers together, I get 1.023. .165 plus 0.687 plus, okay, are those negatives though? Let me see. No, they wouldn't be.
No. Did you square those?
Well, those are squared. That's the after. So the first step was to subtract 37. Like on 113791, you subtract 38075.
Yeah.
And then I get a number of oh, maybe that's where I went wrong. Okay, so that was. Let me see what I did here.
I got 0.165, 0.825, 0.905, 0.085.
On your squared?
Yeah. Well, no,
okay.
no, like that's before I squared it. After
okay,
I squared it.
So you get 0.165 negative?
Yep.
And then negative 0.825?
Yep.
And then 0.405?
0.905 is what I got on that one.
Oh, on the fourth? Okay, let me check that. 38.48, or is it 98?
98.
Okay, that's where I'm probably going wrong. Can't read my own handwriting. 98 minus 38.075. Okay, and then square that. So it's 0.905. And then it gives, once you square it, it goes to 0.819.
Yep.
Okay. And then the last one, did you have 0.007 after squared? Okay, and then what did you have after it was squared on the first one?
0.027225. Wait, just the first number?
Yeah.
Yeah.
Okay, so 0.027?
Yep.
Okay. Okay, and so add these all together, 0.027 plus 0.681 or 687, the second one.
I did the whole thing, so I did 0.680625.
Okay. Plus 0.819 plus 0.007. Okay, so I get 1.5 0.34,
Mhm.
and then I'm going to divide that by 3, which gives me point.
I thought you divided it by 4.
Well, is there 4 or 5 total? There's 4, right?
Yeah.
Yeah, and then you subtract 1 from that number, and that's what you divide it by.
Oh, crap.
Okay.
That's where I went wrong.
Yeah, it's n minus 1. So you take the total number of samples, and then you subtract a 1 from it. So
what was the total again, I guess, after you added all those up?
yeah, it's 1.534 was the total.
Divided by 3.
And divided by 3, it's 0.5113333 or whatever.
Yeah.
And then you take that number, and we're going to square it. So and I get 0.714, which I think, or 15, which I think was the number that was on my quantitative descriptive thing. So let's see. Yes! Yay! Oh my gosh. So now that matches. So now the standard deviation on that quantitative descriptive app that they have is 0.71509, and I came up with by hand 0.715.
Okay.
So, okay. So that was Okay, so 14 should be 0.715. Okay,
Yep.
Under certain conditions, the standard deviation can be negative. I put false, but I couldn't remember.
Yeah. You're not. Well, no, because even if you had negative numbers, your
It would go
standard deviation is
positive.
still going to be positive because it's not below 0. It's the difference between these numbers.
Right.
So it'll never be 0 or negative.
Yeah, that's what I thought. It has to be 0 or, yeah, so. Okay, in the same study, the researchers placed blah, 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 blah. So which location resulted in the most consistent temperature measurements from one seal to another? And I have that would be by the standard deviation is what I went by, and so I put the extradural. What do you think?
Most consistent temperature measurements from one seal to another.
Because it would be the smallest deviation. It would make the most consistency.
Oh, yeah, okay. I was reading that wrong. I was like, but 0.57 is not even close to 1.54. No, I get it.
The extradural as the,
Yep.
because that's the small standard deviation, that's the most consistent temperature.
Yep.
Okay.
Because we're not talking about from arterial to hepatic sinus. It's talking about the measurements within each of those.
Yes. Yeah, there's like 6 for arterial, there's 3 for extradural.
The smallest standard deviation is winner.
Mm-hmm. I mean, there is smaller sample size, though, for extradural, but that shouldn't make a difference, right?
Yeah, no, I don't think so.
Okay. I can divide standard deviation in my own words. Yeah, I can. I kind of. What about you? I figure it represents the variance or spread around the mean. So.
Yep.
Okay. All right. So the number of hours spent studying for an exam are recorded. The data are represented by the box plot below. Use this box plot to answer questions 19 and 20. What is the third quartile? Okay, so that would be 8. Right?
First, second, third. Yeah, 8.
Okay. What percentage of the data lies between 4 hours and 8 hours? 50%.
50%. That's what I was just going to say. We just put 50 in there, right? We don't.
Yeah, because it says don't include a percent sign. Okay. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 ppms. And values outside of this range are unusual. We will assume that 1.59 ppm is the value of mu minus 2 standard deviations, and the mu plus 2 standard deviations is equal to 2.52 ppm. It is reasonable to assume the measured nitrate concentration is normally distributed. Use this information to answer questions 21 and 22. Well, but then this is questions 20. Okay. Estimate the mean of the measured nitrate concentration in Rexford's drinking water. Okay, so I kind of just factored this out, but I came up with the 2.055. Because if you...
Yep, that's what I got.
Okay, good. Because if you do minus 2, it comes up to that one number.
Mm-hmm.
Does that sound right? Okay.
Yeah.
So, was that rounded right? 2.055?
Yes.
Okay.
3 decimals.
Okay, estimate the standard deviation of the measured nitrate concentrations in Rexford's drinking water. I have 0.2325. But it's probably 3 decimal places, so 2.33.
Yep.
And how did you find yours? I just took the mean divided by, let's see, how did I do that? I didn't write down how I did it. I'm like, that's the, where you take the,
you take the difference between the two and just divide it by 2.
Take the difference between.
So it's 0.465 from the 159 to the mean, and it's the same from 2.52 to the mean.
Okay.
And then I just divided those by 2, and that's how I got 0.23.
Oh, okay. Oh, that's right. That's how I found it out, I think, too. So, like, okay. Oh, yeah, I got that up there. All right. That's how I found the subtraction. I kind of had to divide it. Yeah. Okay. I was sitting here, how did I do that? Okay, 0.233. Between what two measurement nitrate concentrations do approximately 68% of the data value lie? I have 1.82, well, but it would be rounded up. 1.8225 minus between that and 2.2875.
Yeah, pretty sure that's what I'm getting right now. Hang on, I'm doing it by hand.
Okay.
Yeah, that one for sure.
Okay, it doesn't round it up on that first number, but that's okay. It seems to be the closest to that answer, the 1.822 and 2.288.
Yeah.
Okay. What is the value of the mean of the standard normal distribution? It's the, like, oh, is it asking it for this? Okay.
Isn't it the average between 1.822 and 2.288? Oh, wait, standard normal. Oh, no. I had no idea.
I didn't realize that this was connected to this question, to this example above, because it only says 21 and 22. So I thought that it was just, mu divided by n, like.
Oh, so they're asking the equation. What is the equation?
I think so, but I don't know how to answer. I don't know how to input it in here. I mean, maybe they want the thing above, but that doesn't.
Oh yeah, they only said 21 through 22.
Yeah. Well, and it actually included 20 too, but they didn't. I don't know. I just don't know how. I don't know how to enter the mute the O. Yeah, that O sign divided by square root of n.
Yeah.
Okay, so.
Can we copy and paste the?
Maybe we just need to use that example above.
That'd probably be the safest bet.
Okay, so what is the value of the mean of a standard normal distribution? It would be normal, right? Or is it just asking whether it's a normal or distribution, or?
I don't know. See, that's what I'm not getting. Are they asking for like an actual number?
Yeah.
Equation? Just a word answer?
I think it's just a word answer. Maybe it's not an equation. I was thinking like standard deviation, but I don't. This is saying what is the value of the mean of a standard normal distribution? It's just normal, yeah. Or is it approximately normal? But a standard normal distribution has a mean of 0 and a standard deviation of 1. Okay, so a standard normal distribution has a mean of 0 and a standard deviation of 1. So it's 0.
That's easy.
This was in the review, on the lesson, the review lesson. It has like where you can look at the reviews, and I just kind of copied and pasted for my cheat sheet off of all of those and made it in really small font, but that's what this says. Yeah, a standard normal distribution has a mean of 0.
Well, and the next question is a standard deviation of a standard normal distribution, so that's just 1.
Yes, standard deviation of a standard normal distribution is, it says 1. Yep.
Perfect.
All right. Okay, Bowen, give me a minute, okay? Yeah, but I'm still in my meeting, honey. I'm talking to someone. See? Here, look. See? Look.
Hey, buddy.
Yeah, he can hear you. Okay, go on out. I should be done in just a few minutes, okay? I'm taking a quiz. So he's still not feeling great, I could tell. Okay. Back on to this. Okay, so yeah, that's 1. Okay, we're getting there. Okay, so this is like all that probability stuff. So what is the probability that a randomly selected student will score above 542.3 on the GMAT? Okay, so this is what I had a hard time with because there was nothing to subtract because the mean is 542.3. So since it's equal, that means it's 0, right?
I think so.
So if that's the case, then I came up with
This is the mean minus the difference.
Divided by the standard deviation.
Okay.
Right? And since it's 542.3 minus 542.3, it's 0, and I think I end up with a like a 50% or something. I'm trying to remember. Let's see. What number is this? This is 25. No, that's not the right one. Yeah, I'm trying to remember. Let me try to pull up the app.
Okay.
I should have pulled it up before. Okay, main page. Okay, so if you take 0 and you divide it by the, what's the standard deviation on it? It's just 0. So if you enter a z-score as 0, it puts the line right in the middle at the mean. And then what they wanted to know, greater than, not less than, right? It's 50.
Or above, yep, 152.
So
That's just
yeah,
50%.
it's just 50%.
Down to the nearest 10. So it's 0.5?
Yep. 0.5. What is the probability that a random selected student will score below 600 on the GMAT? So then I took 600 minus 542.3 divided by 120.54. That equals 0.4787. And I plugged that into the probability app. 0.4787. And
Isn't it 0.684?
uh-huh. Yep, 0.684. I just wanted to double check, but that's what I got last night, and I got that again. Okay, 26. What is the oh, go ahead. What's
You
that?
said it's just the opposite.
Yes.
0.316.
Yes, 0.316, you're right. Okay, and then this is find the GMAT score that corresponds to the 10th percentile. Round the nearest whole number. So to find the percentile, you go into the probability app and you enter 0.10, and you want it to be shaded to the left of the number. So I get a negative 2, let's see, a negative 1.282.
Yep.
Okay, and then I have to figure out the x, which you have to, when you factor it all out, I come with up with 387.8. It'd be 388. What do you come up with, though?
So it's...
So you take a negative 1.282 equals x minus 542.3 divided by 120.54. And then you multiply each side by 120.54 to get rid of the denominator.
Mm-hmm.
And then you get negative 154.53 equals x minus 542.3. And then you add 542.3 to both sides. I get 387.8. So if you round it up to a whole number, it'd be 388. Does that sound right?
Mm-hmm.
Okay. And it says find the GMAT score that corresponds to the 90th percentile. So it's the same, but it's a positive 1.282. Mm-hmm. And when you factor it all out, I come up with 930.1. So 930. Okay, and it says find the first quartile of the distribution of GMAT scores. Round to the nearest whole number. So the first quartile would be 0.25, right?
Mm-hmm.
Okay, so I get a z-score of a negative 0.674.
Yep.
Equals x minus 542.3 divided by 120.54. And that leaves me with a number of 461.1. That's how it factors out, but tell me if you get something different.
No, that's what I got.
Okay, good. Okay, and then the third quartile is 0.75. And I come up with, on that one, a z-score of 0.674 positive, and I factor that out to be 623.5, so I would round it up to 624. But you factor it out really quick.
That works for me.
Do you get the same?
Yeah, 624.
Okay. And 31, it says find the third quarter. Oh no, not 31. 32 says consider a simple random sample of N15 students taking the GMAT. What is the mean of the distribution of sample scores for all such samples? Round to the nearest 10th one decimal place. So I have the mean being 542.3 because it's normal.
Mm-hmm.
Is that right?
Mm-hmm.
42.3. It says, what is the standard deviation of the distribution of sample mean scores for all such samples? And that's where you take the 120.54 divided by a square root of 15. And I get 31.123. I'm going to just double check that answer just to make sure. Yeah, I get 31.12329,417. So
Perfect.
So 31.123?
Yep.
Okay, and it says what is the probability that the sample GMAT score for an SRS of N15 students will be greater than 600? And so this is where you enter the, you do 600 minus 542.3 divided by 31.123 equals 1.854, and then you enter it into the probability app, and it's 0.032. Just make sure you get the same thing.
It's above 600, right?
Yeah, the question says greater than 600.
0.0319.
Yes, I got.
But yeah, round it, so 0.032.
0.0319, so 0.032. Is that right? Okay.
What did you have for 30? I think I did that wrong.
I have 461. So let's make sure.
Okay.
Is that right, or let's see?
No, yeah, it is. I did some math wrong on it, and I.
Okay, I'm just gonna. Okay, so you think that's right, or should we go back over it?
No, I think that's right.
Okay. All right. Well,
were there any that we had questions on that we want to look over again, or?
I don't know. I'm just kind of done with this. I'm like.
Yeah.
I don't know. I don't think there was anything. I think the only one that we spent a lot of time on was the square deviation sum, but I think we were right on none of these is correct. So. Okay.
Let's submit it.
All right.
I submitted.
I did too.
94.
Oh, well, you got it. What?
How'd you get a different answer than I did?
I don't know. Okay.
So I missed 4.
I missed 4 too.
Okay.
Okay, so that was not a simple random. That was something else. That was probably stratified. Okay.
I missed 9.
I got 9 right. I had 1.912.
912. I put 1.192.
Oh, I'm
Crap.
sorry. Oh.
That's all right. I just misheard. And then I missed 29.
Okay, I probably missed that too. Let's see. Yeah, I missed that too. Find the GMAT score that corresponds to the 90th percentile. Well, I wonder how I did that wrong. 90th percentile, let's see. 0.90. I'm going to go less. Okay, so I get a z-score of 1.282. And then you take it and you, that equals 542.3, x minus 542.3 divided by 120.54. And then you multiply, let's see, 1.2882 times 120.54. I get 154.532, and then you subtract, or see, you're adding 542.3 to that number, so plus 542.3, I get 696.832. So maybe it was off by a number. Let's see. I should have probably redone that one. Oh, yeah, it was off. It should have been 696. I don't know where I got 930 from.
That's weird.
It should
But
have
hey,
been,
we still got A's.
Yeah, that's fine. 696.8 is what it, or 697 should have been the number. Oh, bummer.
Yeah.
That would have, if I would have redone my math, I would have caught that, but I just was like, oh, I'm done with this, and the kids were yelling at me. So, okay, well, we tried.
Good.
Yeah, we did. I'm sorry that one was just a miscalculation. I'm like, we should have got the same number.
It's all right. I still got 91. I'm okay with that.
Yeah. Okay. Well, I'm glad you're okay with that. All right. Well,
Cool.
yeah, I think we're done for today. So, good
Great.
luck on your test.
Likewise. Thank you.
All right. Take care. Bye-bye.
Yeah.
Can I have lunch?